Hey kids, welcome to section 2.3, other types of graphs. Today you're going to learn how to represent data using bar graphs, Pareto charts, time series graphs, pie graphs, dot plots, and also stem and leaf plots. So taking all of our data we've been collecting and now talking about what kind of graphs, in addition, can we put them into. First one we're going to talk about is a bar graph. And so when the data are qualitative or categorical, a bar graph can be used to represent the data. Remember, categorical and qualitative bar graphs, those kinds of data are ones that are describing things without using a number. It is simply by a characteristic or some kind of quality. A bar graph can be drawn using either horizontal or vertical bars. So depending on what you're trying to get across or who the audience is that is going to be looking at this, you might put it one way or the other. Bar graphs can also be used to compare data for two or more groups. These types of bar graphs are called compound bar graphs. And so you might have some kind of study where you were comparing Coke versus Pepsi for males versus females. And so you might be putting bars for Coke and how many of each liked that, and then you might have how many of each liked Pepsi, and so the different bars can then be compared. So our example here is all about college spending. The table shows the average money spent by first-year college students. Draw a horizontal and vertical bar graph for the data. All right, so the first one we're going to do is the horizontal. So when you do the horizontal, you're going to be putting the categories or the classes along the bottom. So we have electronics, dorm decor, clothing, and shoes. So we're going to have for along the bottom, we're going to have electronics. We're going to have, maybe I should go sideways, dorm decor. And then we're going to have clothing and shoes. And then along the vertical, you're going to have your frequency. The values. I need to go from 72 to 728. So I'm thinking maybe I'm going to count by hundreds. So there's 100, 2, 3, 4, 5, 6, and 7. So then you'll want to label these, or at least every other. Also label your axes. So along the horizontal, we have categories maybe of things that dorm kids spend their money on. And then the vertical is dollars. So you're going to want your bar to straddle the tick mark at the bottom for the category. So since electronics goes up to 728, I'm going to try to be as vertical as possible, but it's really hard to draw straight lines. And then dorm decor goes up to 344, so you kind of estimate where 344 is. It's maybe about here. And your bars do not touch in here, unlike a histogram where they do touch, and you want them to kind of be the same height, or same width. And then clothing is 141, so let's see, that's we'll go right here. And then shoes is 72. So there is a vertical bar graph for the different categories college students spend their money on. That's your vertical one, my bad. That's your vertical one because the bars go up and down. Here's a horizontal because the bars are now going to go side to side. So since your bars are going side to side, that means your categories are along the vertical. And it does not matter the order you put them in. So we can do electronics at the top, and then we can do dorm decor below, then clothing, and then shoes. So these would be your categories. And then you would put your dollars along the horizontal, and this is where we go 1, 2, 3, 4, 5, 6, 700. And this is 100 and 300 and 500. And now your bars are gonna go side to side. So clothing is 72, so that one's gonna be like that. And clothing or shoes was 72. Clothing is 141, which is going to be about here. And then decor, dorm decor, 344 is going to be about here. That one is a little bad, but we'll just make that look nice. Oop, there it goes. And electronics was 728, so we're going to go, this one's all the way out here. So again, notice how the bars are straddling the tick marks for the categories. The bars are not touching, and they're relatively the same width. That is the bar graph. Visually, I can now tell which category has the most, which category has the least, and the order that they are in. They are not always going to go on a downslope like this. They can be in any sort of order. Okay, next type we're going to talk about is called a Pareto chart. And when the variable displayed on the horizontal axis is qualitative or categorical, a Pareto chart can also be used to represent the data. When you analyze a Pareto chart, you're going to make comparisons by looking at the heights of the bars. So a Pareto chart is basically a bar chart that has been put in biggest to smallest order. And so it's basically kind of what we did before. But the data is not always going to be in beautiful order, and so you're going to have to kind of put it in order. We're going to make the bars the same width. We're going to arrange the data largest to smallest according to frequency. And we're going to make the units that are used for the frequency equal in size. So it's kind of like a bar chart, but in order, always. So maybe make yourself a little note that a Pareto chart is always in order from highest to lowest. So our example says the data shown here consist of the number of police calls for a specific categories that a local municipality received in 2011. Draw and analyze a Pareto chart for the data. So basically what you're going to do is you're going to look at your categories over here. There are 5 categories, so we're going to go and put 5 categories over here. Okay, and so these are going to be our categories. We're going to label them as juvenile complaint. So let's see. Sorry, I'm trying to write sideways. Juvenile complaint. And then we have loud noise. And drugs offenses. We'll just put drugs. And then driving under the influence. We'll put a DUI. And then disabled vehicle. We'll put disabled vehicle. All right. Oh, actually, pause. We need to put these in order from smallest to biggest. Good thing I'm totally thinking. So let's take a look at our numbers, and we need to put them in order from smallest or biggest to smallest. So where's your biggest one? The biggest one is 92, which goes with juvenile complaint. So we were right with the first one. Juvenile complaint. Then find your second biggest one. Sorry, kids, for my craziness. Second biggest one is 79. That's drug offenses. So we're going to put drugs second. Then we're going to find the third one, which is 65, which is disabled vehicle. Disabled vehicle. And then the fourth biggest is 38, which is driving under the influence, DUI. And then the last one is loud noises. Okay, so now we've got our categories in order from biggest frequency to smallest frequency. And now we can go ahead and put our vertical. We need to go all the way up to 92. So maybe by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90. It works. We'll just make it work. 10, 30, 50, 70, 90. And these are the number. Okay, so our biggest one is 92, so we are going to straddle the juvenile tick mark and go up to 92. And then drugs is at 79, so we're going to find and approximate 79. And then, and notice that they connect to each other. The next one is 65, so we're talking right about here. And the next one is 38, so right about here. We kind of got off a little bit, but And then the last one is 27. So if it doesn't work, you make it work. So that's called a Pareto chart. It goes in order from biggest to smallest, and it allows the viewer of the chart to know right away the exact order. If you're looking at the bar graphs, they may or may not be put into the proper biggest to smallest order, and you might have to think a little bit about them. But a Pareto chart is definitely in order biggest to smallest. All right, third type of graph is called a time series graph. And a time series graph is used when data is collected over a period of time. So you're collecting data over some kind of period of time, over the last 20 years, over the last century, over the last week, over the last day, any kind of time. When you analyze a time series graph, you want to look for trends or pattern that occurs over the time period. So you could say something like it's constantly increasing, it's constantly decreasing, it's overall remained the same. You can also compare two or more sets of data on the same graph. That's called a compound time series graph. And that's when you're going to use two or more lines, and you might see, you could look at the differences in male age that they crashed their first car. And so you might have all the different ages for the males, and then maybe you want to compare it to females. So you could do some kind of comparison. Here we have, for our example, the data show the percentage of U.S. adults who smoke. Draw and analyze a time series graph for the data. Okay, so if I'm going to draw a time series graph, my time is going to go along the x-axis, which is, in our case, years. So we've got years along the x-axis, and there are 5 of them. So we've got 1970, 1980, 1990, 2000, and 2010. Then along the vertical, we're talking about percentages here. So we're going to put percentages. Now, whether you want to change those percentages to a decimal or if you want to leave them as whole numbers, that is your choice. It looks like they're going up to 37. So I'm going to go 10, 20, 30, 40. And then I'm going to put my marks in between for 5s. Okay, so my first dot is at 1970 and 37. Then 1980 and 33. Oh, that's not 37, my bad. That's only 27. 37 is going to go up. Here we go, 37. And then 1980 is 33. And then 1990 is 25. And then 2000 is 23. And then 2010 is 19. After you have all your dots, you connect them. It starts in space and it ends in space. It does not start and stop on the x-axis at all. So what we can see is that overall, as time continued, it looks like the percentage of U.S. adults who smoke has decreased. So we can say there has been a decrease in the percent of U.S. adults who smoke between 1970 and 2010. So analyzing a time series graph, looking for a trend or a pattern over time. Okay, that's the third one. All right, next one is called a pie graph. The purpose of the pie graph is to show the relationship of the parts to the whole by visually comparing the sizes of the sections. The variable is nominal or categorical. So here's another nominal, categorical, qualitative type of graph. So the pie graph is a circle that is divided into sections or wedges according to the percentage of frequencies in each category of the distribution. And to analyze the nature of the data shown in a pie graph, you're going to look at the size of the sections in the pie graph and draw your comparisons from there. So our example here says to construct and analyze a pie graph for the calls received each shift by a local municipality in 2011. So we have how many phone calls were received in 2011 during the day, evening, and night hours, along with a total. So in order to complete the circle graph, we need to figure out the relative frequency, which is something we talked about earlier in the chapter. And so to find the relative frequency, you're going to take each of the frequency values and divide them by the total. So if I do 2,594 divided by 7,830, I'm going to get roughly 33%. If I then do 2,800 divided by 7,830, I'm going to get 36%. And if I do 2,436 divided by 7,830, you get 31%. Do a quick check that these relative percents total 100. If they don't, then you might have entered one in incorrectly, and that's a quick check before you go and start making the pie graph. All right, so I like to put a dot in the middle just for visualizing where the center is. And it looks like all three chunks of my circle are going to be relatively similar, but one of them is going to be bigger than a third, and one of them is going to be smaller than a third. So if I kind of start and I do what looks to be a third, then I don't know, I'm going to make one of my other thirds a little chunkier. So this one's going to be my 36%. This one is going to be my 33%. And this one's going to be my 31%. So you need to label them in some way, but not only with the number, but you need to put it with the description. So day went with the 33, and evening went with the 36, and night went with the 31%. And so if I was going to analyze this, I would say that the three shifts are relatively equal. Three shifts were relatively equal. Although there were slightly more calls in the evening, although there were slightly more calls in the evening. So as long as you are comparing the different circle wedges together and saying something about which one is bigger than the rest or how do they compare to each other. Okay, the next type of graph is called a dot plot. A dot plot uses points or dots to represent the data values. If the data values occur more than once, the corresponding points are plotted above one another. So you're going to have a number line and you're going to have a bunch of dots standing for what the different values are. And each data value is going to get a dot on the dot plot. So if there are 50 state high temperatures, you're going to have 50 dots on the dot plot. And the dot plots are used to show how the data are distributed and to see if there are any extremely high or extremely low data values. You can also see if there are any outliers here. You can also see if there is a trend for negatively skewed distributions or positively skewed distributions, or if something is symmetric. And so you're going to be able to see from where the dots are what the skewage is of the distribution. So here we have the data show the number of named storms each year for the last 40 years. Construct and analyze a dot plot for the data. So what you're going to do is you're going to look in the table and you're going to try to find the biggest and the smallest numbers first. So I see 28 is my biggest number and 4 is my smallest. So that means my number line has to include all the numbers between 4 and 28. So I'm going to start at 0 and I'm going to mark every fifth one. So there's 5, there's 10, there's 15, there's 20, there's 25, and there's 30. So this is how I'm going to start mine, and I'm going to label those 5s. Then I'm going to go back and I'm just going to put the other 4 marks off in the middle. It just makes it easier if you have the number line all set up before you begin. And it's okay that you have extra space. All right, so now what you're going to do is you're going to go number by number and you're going to put a dot above that spot on the dot plot. So we're going to put a dot at 19. And when you put the dots, you're going to want to make them relatively the same size and the same height, because eventually you're going to start stacking them on top of each other. And you want them to not look skewed because one dot is bigger than another. So you just go through and you put dots at relatively the same height. And once you get another number that repeats, then you start stacking them. Like I got to the second column and 15 and 16 were already there, so I started stacking those. And so you just go through and you put a dot every time the value appears. And so it's a little annoyingly time consuming, but it's not challenging. It's just annoying. So we put our dots. Oh, that one looked a little high. So if we get another. All right. Then I'm going to go to 7 and 8 and 8 and 11. The hardest part is just making sure that when you start stacking your dots that you haven't made one stack bigger than the other. Even out your stacks or try your best. It's not going to be perfect. Alright, I'm getting there. Oh, I think I made a mistake. Uh-oh. Okay, I'm just going to compare it to what it's supposed to be. Because I think I lost track. 1, 2, 3. 1, 2, 3, 4 and 3 and 2 and 4 and that's good. And so I think. All right, there we go. So once you get your dots, you can kind of compare the stacks of them. You can see that we start off pretty small and then it got gradually bigger, went down a little bit, got gradually bigger, went down, got bigger, went down, and then this guy over here seems to maybe be an outlier. If I kind of take away that dot, they're kind of all within this smaller period, but once you put this guy over here, then he's making it into a tail, which is going to positively skew the distribution. So we could say that the majority of the storms, because that's what we're talking about, were between majority of the storms were between 6 and 16, and there is one possible outlier over there at the 28. Possible outlier of 28 storms. Okay, that's a dot plot. Next one is called a stem and leaf plot. Stem and leaf plot is a method of organizing data and is a combination of sorting and graphing. So what you have in a stem and leaf plot is you have the values in the data are kind of split apart into tens digits and ones digits. And so it allows you to kind of see the variation of numbers within a class without having to write like every single number. And so when you analyze a stem and leaf plot, you're going to look for peaks and gaps in the distribution, see if the distribution is symmetric or skewed, and then check if the variability of the data by looking at the spread, if it's very spread out or if all the numbers are kind of close together. So the example we're going to talk about is an insurance company researcher conducted a survey on the number of car thefts in a large city for a period of 30 days last summer. The raw data are shown. So part A says to construct a stem and leaf plot by using the stems 5, 6, and 7. So when you make a stem and leaf plot, you have this, what looks like a T-chart, but one side is much longer than the other side. And so on the left-hand side are going to be the stems, which are the tens digit. And the right hand is the leaves, which are the ones digit. So if you look in your data table, I see numbers in the 50s and the 60s and the 70s. So I'm going to put as my stems 5, 6, and 7. Now what you're going to do is you're going to find all the numbers in the 50s and you're going to put them in order smallest to biggest with their ones digits. So for instance, here is a 50, so I'm going to put a 0 there to stand for 50. Then I'm going to find my 51s, and there are 2 of them, so I'm going to put a 1 twice. Then I'm going to look for any 52s, and there is 1, so I'm going to put a 2. I'm going to look for my 53s. I see 1, and I see 2, so I'm going to put 2 3s. And then I'm going to keep going. And try to make your numbers the same width, because eventually we're going to look at columns, and we're going to try to see which row has more values. So then we look for 54 and there aren't any. We look for 55s and there's 1, 2, so I'm going to put 2 5s. We look for 56s, which there is 1. I look for 57, which there are 2. And then 58, there is 1. And 59, there is 1. Then you do all the 60s and you repeat the process, and you try to stack the columns to be the same width. So 62 is the smallest, so I'm going to put the 2 under the 0. And then there's a 63, so the 3 is going to go underneath the 1. There's no 64s, but there's 2 65s. And then there's 2 66s. And a 60, there's a 6 7. There's a 6 8. And there are 2 9s. Then you do the 70s. Okay, so 72 and 73 and 2 75s and a 77, a 78, and a 79. Okay, so there's our stem and leaf plot. The other thing you should do is you should put a key down at the bottom, because most people, when they look at a stem and leaf plot, have no idea what it means. So I usually pick the first pair right here, 5 0, and we're going to go 5/0 equals, and we're going to say that this is 50 thefts, just so someone can interpret. Notice also it looks like with 3 categories that the 50s have the most, the 60s have the middle, and the 70s have the least amount. But it doesn't really tell you much because they're only groups of 3, so you can't really say like what part of the 50s was bigger than the other. So that's why part B is here. Construct a stem and leaf plot by using the classes 50 to 54, 55 to 59, and so on. Well, what this is doing now is this is taking our stem and leaf plot and we're going to expand it so that we have 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, and 75 to 79. And we're going to group them, instead of in all the 50s, we're going to group them in half of the 50s. So if you look, you're going to go over here. I got 0, and I got 1, and 1, and 2, and 3, and 3. It says to stop at 54. So the 5 start in the next row. So there's a 5, and a 5, and a 6, and a 7, 7, 8, 9. So the 50s are fairly spread out with the number of thefts. You go to the 6s, and you got a 2 and a 3. And then the rest of it goes in the next one. A 5, and a 5, and a 6, and a 6, and a 7, 8, 9, and 9. And then the 70s are 2 and 3 again. And then it goes into 5 and 5 and 7 and 8 and 9. So now, again, do your key. So this is 5/0 equals 50 thefts. So now this graph gives a little bit more information. We can see that there's a peak towards the higher end of the 50s. There's a peak at the higher end of the 60s. And there's a peak at the higher end of the 70s. The part C says, which graph gives a better visual of the distribution? Well, definitely the second one. The second one, because it gives you a more defined look at the individual classes by splitting them up. All right, so sometimes splitting up the classes gives you a better picture, but sometimes you can do what's called a back-to-back stem and leaf plot. And so related distributions can be compared using a back-to-back stem and leaf plot. And this is where you use the same digits for the stems in both distributions, but the digits that are used for the leaves are arranged in order out from the stems and on both sides. So for instance, we have the number of stories in 2 selected samples of tall buildings in Atlanta and Philadelphia. Construct a back-to-back stem and leaf plot and compare the distributions. So the data on the left is Atlanta, so I'm going to label that one as Atlanta, and the one on the right as Philadelphia. Now look at the data. I have 20s all the way up to 50s in Atlanta. Oh, there's the one in the 60s. Is there one? Yep, 60s. So 20s to 60s in Atlanta. And over in Philadelphia, I have 20s to... Oh, there's a 70 over here in Atlanta. So 20s to 70s for Atlanta. And Philadelphia is 20 to 60s. So we're going to go to incorporate all of them. We're going to go 2 through 7. So 2, 3, 4, 5, 6, and 7. So even if only one of the sets of data includes a stem, you have to include it as well. Also, if there's a stem that does not have any leaves that go with it, you still have to represent it here. So let's say there was nothing in the 60s. I would still have to put a 6 here for the stem, and I just wouldn't have any leaves on either side. It would be blank. Okay, so now you're going to go and you're going to find all the numbers in the 20s. So we have 26, and there's a 29, and there's a 28. Now, when you put them on the Atlanta side, you have to put the smallest one towards the middle and then go out from there. So it seems very strange to do the Atlanta side. And then you're going to do the 30s. And I've already done this, so I'm not going to have you stay there and go through this with me. But 1, and then there are 4 2s, and then 4 4 6 8. And then the 4s are 0 0 4 4 7, and then the 5s are 0 0 2 2 3 5. It's hard to write them backwards. It's weird. 0 and 3 and 0. And then you do the same thing on the Philadelphia side, going out from the center. So this is like the normal side. Then there's zeros. The 3s are 0 0 0 0, 2 2, 3 4, 6 6 6, 8 8, 9 9. And then the 4s are 0 0 0 0. The 5s are 0 3 4 8, and then 6 1. And there's none in the 70s, so we leave it blank. Make sure that you have a key. So I pick the one in the center. So I go 6 2 5, and so 20 or 6/2 means 26 stories Atlanta. And then the 2 5 is going to be 25 stories in Philly. So it does say to compare the distributions. Well, we can say that it looks like the Atlanta buildings are have more variation in them. The reason why is because the numbers go from 26 all the way up to 70 versus 25 to 61. So we can say there is more variation or differences in the Atlanta data. It also looks like the majority of the Philadelphia stories are in the 20s and 30s. And it looks like Atlanta might have overall taller buildings as well because it has more data in the upper range. So something about, the Philadelphia has more buildings with stories in the 30s than Atlanta has with buildings in the 30s. Something about a comparison. Okay, we've learned them. So now we're going to talk about misleading graphs. We talked a little bit about this in chapter 1 when we talked about the misuse of statistics, but we're going to talk even more about it now. Graphs give a visual representation that enables readers to analyze and interpret data more easily than they could simply by looking at numbers. That's the whole point of this chapter, kids, is that we are looking at how do we take the data, put it into some kind of graph so that somebody can learn something intelligent about it. However, inappropriately drawn graphs can misrepresent the data and lead the reader to false conclusions. So things like changing the units at the starting point on the x-axis. That's what this first one is looking at. Changing the, or on the y-axis, changing the units starting at 50 versus starting at 0. When they start at 0, they're very similar. When it starts at 50, there's a big discrepancy between them. Exaggerating a one-dimensional increase by showing it in 2 dimensions. So if you were to take, say, a square, but all of a sudden it's representing a prism, a rectangular prism, then you might have some issues with it. Omitting labels or units on the axes of the graph. It's really important that you label all your axes. I told you that earlier in the chapter. And it's, you need to know what you're looking at. All graphs should contain a source for the information presented. You should never be given a graph blankly and say, well, here's the graph. The graph should always have some kind of narrative behind it explaining to you where the data came from and when they took it so that you can look at the validity of the data and therefore rely on the answers. Last one, it's not wrong to truncate an axis on the graph as long as it is used appropriately. So if you're going to say chop off the bottom of this first graph, you need to make sure that it's going to not disturb your data representation in any way, but that it's going to appropriately show the differences. This pink diagram here, when you look at the picture, if I put team A, team B, team C over here, 50, 64, 38, that might be a little misleading because they kind of all look the same. So if you don't have the percentages on them, it might not be telling what you want it to be telling. But maybe this is a bar graph representation, gives you a better visual of which one is bigger. Because if you don't label them with the percentages, then how are you going to visually tell? Here's another example, a misleading example. This one might be talking about how, well, you got May, you got June, you got July, you got August. It looks like it's always going up, but what are the units? I don't understand what the units are for. What are you measuring? What's going on in 2019 and 2023? I mean, this might be a little better, but again, what are we talking about? This graph right here is using not the entire vertical axes. If I use the entire vertical axes by labeling it as such, I've got all this dead space above it. But over here, this one's more accurate because we are cutting away all that dead space, and now we can see the changes more clearly versus the little changes. And then this one down here at the bottom, we have individuals per kilometer and individuals per kilometer, but it doesn't tell us if the 0 is good or if the 0 is bad, or why is on one graph Illinois darkly colored but on the other graph it's lightly colored. Like, what's the difference? Should you be showing is darker better, is lighter better? Make sure that you're always labeling and explaining. All right, we have a time series graph. This is a compound time series graph where you're comparing more than one thing at a time. The graph shows the number of deaths in the United States due to accidents. Answer the following questions about the graph. So first, name the variables that are being used in the graph. Well, you have year at the bottom, you have number of deaths on the vertical, and you have different causes of death. So we have year, a number of deaths, and causes of death. Letter B, are the variables qualitative or quantitative? Well, the year is quantitative. It is describing a number. The number of deaths is also quantitative. It is using a number. So we'll just put number of deaths and year. These are both quantitative. Cause of death is qualitative. That is putting something into a category, not using a number. All right, which type of graph is used here? This is a time series graph. Time series graph shows changes over time. Which variable shows a decrease in the number of deaths over the years? Well, B looks, or drowning, the purple one here, looks like it's basically staying the same. It decreases, increases, decreases, increases. The orange falls one looks like it's constantly increasing. The green poisoning one also looks like it's constantly increasing. The motor vehicle one is the only one that I could see doing a big decrease. So I'm thinking motor vehicles. And if you compare, it started at about 42 and it ended at about 35. So we can say from 42 to 35. So that shows a decrease. Which variable or variables show an increase in the number of deaths per year? Well, let's see. The drowning pretty much started at 4 and ended at 4, so not that one. We can do falls. Falls went from about 14 to about 26. And it looks like poisoning also increased. Poisoning, that's a no. Poisoning. And they went from 11 all the way up to about 39. All right, so we had 2 increase, 1 decrease. The number of deaths in which variable remains about the same? And that would be drowning. It's the one that pretty much stayed the same. List the approximate number of deaths for each category for the year 2001. So the year 2001, I want these right here. So the top one is motor vehicles. That would be about, we'll say 44. And then we got poisoning. We'll say poisoning is the green one. We'll go with 14. And then we got falls, which is right below it. We'll say 13. And then we got drowning. That looks about 3. In 1999, which variable accounted for the most deaths? In 1999, it was the blue one, which was motor vehicles. In 2009, which variable accounted for the most deaths? That would be poisoning. And finally, in what year were the numbers of deaths from poisoning and falls about the same? So poisoning and falls was about the same during 2000, I don't know, maybe 2002. Looks like it's going to be right in the middle. All right, kids, that is the end of section 2.3. There's a lot of information, so if you have any questions, please let me know. And as always, keep calm and keep trucking.